All right, welcome back. Last one, last part of this question asks us to consider the case where the central bank chooses pi equals 0 and everybody believes that they will stick to it. I didn't use the proper words for these two cases in the first question, and I should do that. So just to be clear, that we call the first case the discretionary case. Let me slide my canvas over a little bit here. Okay. We call the first case the discretionary case. So that's right here. We wrote this as U discretion. So discretionary implies that the central bank is free to choose any inflation rate. And then we can contrast that with the commitment case. The commitment, which is the central bank announces a pi and everyone believes them. So the idea is that instead of trying to play this game where the households pick, the central bank just commits and it says pi will be this, regardless of any factors. Whatever shock comes, whatever happens, it's just going to be this. And so expected pi will always equal pi. Yes. And we know that the best possible loss case for inflation is pi equals 0. So let's consider the social utility, the expected social utility, which we know is equal to just the the utility of the central bank, given that pi equals expected pi equals 0. Okay, so we remember that the utility of the central bank, the expected utility of the central bank, and has a functional form. Let's write it on the same line, why not? It's minus is the expected value of minus 1/2. I always forget the lambda. Minus lambda over 2, y minus k squared, minus 1/2 pi squared. But right away we know that pi is locked to 0, so we erase this. That's nice. Okay, we need to unpack y. Okay, we recall that y is equal to yn plus a times pi minus expected pi plus epsilon. Both of these are 0. We buy the scenario, both of these are 0, so we get y equals yn plus epsilon. So let's plug it in. We get that the expected UCB given is equal to the expected value of minus lambda over 2 times yn plus epsilon minus k squared. Okay, and then we will do this square. Once again, I'm going to group yn and k. So we'll get the expected value. I can pull out the minus lambda over 2 as well, because that's deterministic. And it's a common factor to everything. So we'll get yn minus k squared plus 2yn minus k epsilon plus epsilon squared. Okay, and we know how to take expected values now. We've had a lot of practice with this. We know that this goes to 0. We know that this goes to sigma squared epsilon. So the answer just becomes minus lambda over 2 expected value of nope, sorry, no expected value, I already did that. Lambda over 2 yn minus k squared bracket here plus sigma squared epsilon. And we're done. This is going to be expected UCB in the commitment case. In the commitment case, given pi equals 0. And then, writing commitment here implies that the expected pi equals pi, because the people believe that the central bank says there will be 0 inflation. They say, okay, you can do it. And it's whatever, come what may. Come what may. So the social loss we can compare this to the discretionary case. So in the discretionary case, we have all of these sensitivity parameters that show up and essentially scale the commitment case. So the additional social loss is proportional to these parameters. If the central bank and the central bank's sensitivity to the output gap relative to its target and the economic sensitivity to additional inflation are both very high, then the additional social loss from discretion will be higher. And that makes sense because in that case, then the central bank is going to try to play the game more. It's going to play harder. It's going to fight for a higher rate of growth, which implies a higher rate of inflation, which implies more social loss. But we still have sigma squared epsilon. This should make sense because the shocks are still in the model. Shocks still come and people still lose welfare from when the shocks push the system off of the target. I shouldn't say people, I mean the central bank loses welfare. And then the central bank also loses welfare from ignoring its target. So it wants the economy to be at K. The economy is actually going to be at Yn in expectation. And so it loses that. It foregoes this. There's nothing you can do about this. But then it also, and then it also loses from the shock. There's nothing you can do about the random shocks. So you see only the things that it has no control over are left. But we do better because 1 plus a squared lambda is always bigger than 1. So this should always be smaller than this, as long as a and lambda are bigger than 0. Okay, so that's that. How much utility is lost by the bank trying to hit the target K? It's just going to be this, right? Yeah. You could subtract this from this, I suppose, and you would get the actual thing. I'm not going to do it. But the amount of utility that is lost when it actually tries to use its discretion to hit K is going to be the discretion minus the commitment. And then we would see what that actually was. Okay, that's that. And we'll move on to the final question, which is going to be very largely the same, but with a little bit of a twist.